I want to revisit the graph that we just did. Y equals to negative x squared plus 6x plus 16. Now, when we drew the graph, I said at 3, 25, there's this vertex and it comes down like that, right? Now, a parabola is symmetric with respect to the line, the vertical line that passes through the vertex. Okay. So that's what we call as the axis of symmetry of the parabola. Okay. And I want to give you a formula for the axis of symmetry. And we already know that here's 8 and here's negative 2. And because it passes through 3, what's the axis of symmetry for this one? It's 3, right? X equal to 3. You should all know that if you do x equal to a value, it gives you a vertical line. So this equation of this vertical line is x equals to 3. So the axis of symmetry for this equation is x equal to 3. Now notice that 3 also happens to be exactly midpoint between negative 2 and 8. How do you get the midpoint? You do the average, right? So you have negative 2 and 8, add them together, you get 6, and divide by 2, you get 3, right? So 3 is really the average of these two numbers, negative 2 and 8, and it is indeed the midpoint. But we already knew that because I said this is the axis of symmetry. If it's symmetric, then it's right in the middle, right? So it all makes sense. However, we were able to figure out this x equal to 3 by completing the square. I want another formula that we can just plug it in and not have to worry about completing the square, because you know a lot of times completing the square is cumbersome. It takes more time. So if there's a shortcut to find this axis of symmetry, maybe that's easier. Okay. So let me show you how to do that. And the idea is this. It's negative 2 and 8. So I want you to recall the quadratic formula. What's the quadratic formula? X equals to negative b plus minus square root b squared minus 4ac all over 2a. Okay, so that's the quadratic formula, right? Now, in our case, what's negative b? It's negative 6, right? Plus minus square root, whatever, it's usually very hard. 2 times what? Negative 1. A is negative 1, right? This is the standard form of the parabola, and A is negative 1, B is 6, and C is 16, right? So A is negative 1, B is negative 6, something crazy here. Now look, what is this? This is negative 6 divided by negative 2. Can you simplify this?
3.
That's 3. And that 3 is same as this 3, and that's not a coincidence. See, if you look at this quadratic formula, that thing can be written as, do you know how, if you have two fractions like 3 plus radical 2 over 5, you can split this as 3 over 5 plus radical 2 over 5? Do you know this rule?
Sure.
Okay, well, if you don't know, well, some people call this share the love, like share the love. Like shares this 5, and then you have 3 over 5, and right? Good?
Yeah.
All right,
Yeah.
so share the love. All right. So you have this fraction here and this fraction here. And look what you get if you share the love. You get negative b over 2a plus or minus square root something crazy over 2a. Right? So this entire thing is crazy. I don't know. It's just always the most annoying part of calculation. Yeah. But look at it this way. Is this number plus some number or minus some number? It's like this. You have this negative b over 2a on the number line somewhere. I don't know what that is. But it's this plus something and minus something. You go this way and that way, and this, whatever that crazy thing is, it's the same value. Either go this way by that much, go this way by that much. In our case, there's this center, and if you go this way, you create the 8, and you go this way, you create the negative 2. Okay? So what am I? I'm the middle. That's why this is equal to 3, right? And I actually know what this crazy thing is for this one. In our case, it's 5. It must be 5. If we took the time to actually calculate this and divide, we will get exactly 5. So if you do 3 plus 5, you're going to be at 8. 3 minus 5, you're going to be at negative 2. Right? Okay, so I took a lot of time trying to explain the correspondence between the quadratic formula and our picture, but at the end of the day, what am I trying to get at? I'm just trying to say that if you take this quadratic formula and take this annoying part away, what do you get? This is your center. It's the right in between. Okay. This is the axis of symmetry. Right? So here's what the final conclusion. The conclusion is that x equals to negative b over 2a is the axis of symmetry. Does that make sense? Obviously, right? Yeah, just take that and just delete, and then you get the center. That's the axis of symmetry. Right? Let's do a quick example to see the power of this formula. So y equals to negative 2x squared plus 4x plus 5. Okay. Now, I wouldn't imagine trying to perform the completing the square over here, because that would require me to divide by negative 2. Oh, forget it, okay? It's hard. However, we have this formula that gives you the axis of symmetry. Okay, so what is the axis of symmetry for our case? X equals to negative, what's b?
4.
2 times what's a?
Negative 2.
Negative 2. So that is negative 4 divided by negative 4. What's that?
1.
Positive 1. X is equal to 1 is the axis of symmetry. Now that actually tells you a whole lot about this function, because if you have axis of symmetry, right, like here, then somewhere it crosses the vertex. The vertex is literally on the axis of symmetry, right? How would you get the y coordinate of the vertex? So in other words, the x coordinate of the vertex is also this. So this is also same as x coordinate of the vertex. Okay, so this formula that I just erased, negative b over 2a, what is this for? X coordinate of the vertex, and also axis of symmetry for vertex. Okay? Very important. Where do you get this from? You take the quadratic formula, erase the annoying stuff, and that's what you get. Okay? All right. So if you know the x coordinate of the vertex, how do you get the y coordinate? If you have some point on the graph and you know the x coordinate, how do you get the y coordinate? You plug in the value. So you plug in this. So when you apply 1, what do you get? That's negative 2 times 1 squared plus 4 times 1 plus 5. That's negative 2 plus 4 plus 5, which is positive 7. Oh, right. So that means the vertex is at 1, 7. And you know what? This actually tells us the vertex form, because I know that this is h comma k, and if you change this into vertex form, this would be negative 2 parenthesis x minus h squared plus k, and h is 1 and k is 7. So that's what it is. Okay. So we're kind of reversing the process. Instead of straightforward doing the completing the square, we just use this formula to figure out the x coordinate, which is h, and then plugged in that to this function, got the k, and once you have h and k, you have the completed square without doing any work. How nice is that, right?
Nice.
Yeah. And it's pretty awesome, right? Okay. And then if you want to complete this by drawing the graph, you can plug in 0 to get 5. So At 1, you get 7. At 0, you get 5. So you get this. And to get these 2 points, you actually have to use the quadratic formula. Unfortunately, this one cannot be factored, so you have to use the quadratic formula. So let me quickly do that to finish this off. So the quadratic formula says x equals to negative 4 plus minus square root 4 squared minus 4 times 4ac all over 2 times negative 2. So negative 4 plus minus 16, that's 5 times 4 plus 40, 56. And over negative 4, so that's like positive 1. This one has 4 over 56 is 4 times what? 14, square root of 14. 4 comes out as 2. So this is 1 plus minus 1/2 times square root of 14. Okay. Well, I did this quickly, but if you had the time to do it, you're going to get this. So I know that this point is 1 plus square root of 14 over 2, and this point is 1 minus square root of 14 over 2. Okay, that will be the perfect graph. Okay, this will be the in the exam you're going to get questions like change this into vertex form. How do you do it? Do that procedure finding h using this, and then plug it in to find k, right in this form. Okay. Once you have it, you know the vertex. You can easily find the y-intercept and use the quadratic formula to get the x-intercept. You have that, and you can draw the graph. That could be like a whole entire exam question.